In this video, we will learn some basic analysis in stock valuation. This is part of a reading material. I expect to give you one question on the final exam from this learning material. Um, in the end, you will see the analysis we do here is rather simple, and there are no technical difficulties in understanding. So now let's begin this section. It has a very fancy title, right? It's stock valuation, and I start with a warning. We did a lot in bond valuation, right? And relatively speaking, the analysis there is quite accurate. The reason it's simple because the future cash flows of a bond are often very certain, right? Of course, we need to exclude the default risk and credit risk and possibly interest rate risk, right? But nevertheless, if the company that issued those bonds is in good status, then the cash flows are certain, right? We know what would be the coupon payments, and we know the redemption value. Those are specified in the contract, in the covenants of bonds. As long as the company is in good standing, it will pay everything as promised. So at least the future cash flows are certain. Of course, when we price a bond, we need to do a proper discounting. In that sense, there is interest rate risk, right? Because when we do the pricing, well, in most cases, we assume a constant yield, right? Remember, in the bond pricing, there are two important methods. The first one is the constant yield, right? That is the main analysis. We also studied the straight line like a method, right? In that case, the yield or the interest rate is actually floating. Nevertheless, we apply we assume prior knowledge on the interest rates, right? If that is assumed, we are able to price bonds rather accurately, right? But that is not the case for stocks. That's because we don't know the future cash flows, right? The future dividends are definitely uncertain, right? Companies, decide the amount of dividends to be paid, very close to the dividend day. So there's no way we can come up with an accurate prediction on the dividends, right? So that's one. And there is no maturity date, right? Remember, when we price a bond, there is a redemption value, right? That's the value the company is promised to pay back on the bond at the maturity date. But if you hold a stock, well, assuming the underlying company does not go bankrupt, then there is no maturity date, right? You can hold this stock as long as you want, right? You can even pass this stock to your next generation if you prefer. So no maturity date. Okay, and finally, in most scenarios, when we purchase stocks, we actually sell them later on, right? There's no way you can predict the sale price, right? So pretty much everything is it's uncertain. That means there is no accurate way to really predict the price or to really price a stock, right? Anybody who can do that, well, will be a billionaire, right? And obviously, I'm not one of them. That's why I put an objective here. Our objective in this section is rather to provide or to study the stock valuation in a very simplified framework, right? So we only provide a simplified analysis, mainly based on discounted cash flow, right? This is not new, right? When we price a bond, we discount all the future cash flows and add them together. Then that's what we call the price, right? We apply the similar idea or even the same idea here to price a stock. Okay, that's why everything is rather simplified. Okay. Nevertheless, let's begin the such simplified analysis. Okay. Let's start with a simple scenario. So assume right now we are at time 0. So we are trying to find the price at time 0. Okay. Assume that you know the dividend. Assume we know the dividend at time 1 and the sell price at time 1. Again, those are unrealistic assumptions. There's no way I know the dividend in 1 year or the price in 1 year, right? But now let's boldly assume this is the case. Then how do we price? Then the price at time 0 by discounting would be we discount the future cash flows, right? So assume between 0 and 1, there's no dividend, right? There's only one dividend paid at time 1, and at time 1, we sell this stock, okay? So we sell this stock at time 1. So the entire cash flow to us would be dividend paid at time 1, and the final sale price we will receive at time 1, discount by 1 plus R. So here R would be the opportunity cost for such capital investment, right? So usually we call this R, the opportunity cost of equity capital. Of equity capital, okay? Okay, so that is the case of, you buy the stock at time 1, you sell it at time, you buy the stock at time 0 and you sell it at time 1. So what if we buy at time 0, but we actually sell it at time 2? So then we will receive one dividend at time 1 and another dividend at time 2, plus here, because we sell, so we will get another income or cash flow at time 2, that is the price. So if this is the case, then the stock price would be the dividend received in year 1 divided by 1 year discount factor, and then at time 2 we will receive another dividend, and then we sell the stock. P2 is the sale price. Then we need to discount by 2 years, right? So you can easily generalize. So what would be the limit case? The limit case would be we buy this stock at time 0 and we hold it for as long as we can. So let's say infinite amount of time. Then what we receive, the limit case. The limit case is we buy this stock at time 0 and we just hold it, right? And because we hold it indefinitely, we are going to receive the dividend payments indefinitely, right? So in this case, well, P0 would be dividend paid at time t, discounted by t years, and t goes from 1 to infinity, right? So here, I interpret 1, 2 as years. Does not have to be the case because for many stocks, if they pay dividends, usually they pay more frequent than once a year. Right? Usually it could be once a quarter. Okay, so in that case, the time unit would be per quarter, and R would be the opportunity cost per quarter instead of per year. Right? So we just need to match the interest rate or the opportunity cost with the frequency of dividend payments. So the analysis so far is rather simplified, right? Because I assume I know the amount of dividend at time t, and I assume the same interest or the same opportunity cost are across all time, right? From 1 to infinity. This, well, both assumptions are unrealistic, right? There's no way I can predict the dividend payment 10 years from now, and there's no way the interest rate will be the same, over the entire 10 years or 20 years. That's why, at the very beginning, I call this rather simplified analysis. The most important message is that if we know the future cash flows and if we know the interest rate, we can apply the discounted cash flow method to price a stock. As a matter of fact, we can apply the same method to price any financial products that generate future cash flows, right? That is the general case for the analysis done here. Now let's study a few special cases. The first one is level dividends. Well, meaning all the dividends, the DIV are the same, right? In that case, this will be dividend at 1 divided by R. The reason is because then this becomes perpetuity. Right? Assume we buy this stock and we hold it indefinitely. Then what we receive is a periodic payment. Right, it's level, right? Since it's level, so we will receive the same amount of dividend every period, right? Indefinitely. So that's exactly the definition of a perpetuity. So it will be the level payments divided by the interest rate. So that's the price of a stock. Well, here we have an example 6.15. Assume a stock is expected to pay dividends at the rate of $10 each year at the end of the year. Assume the interest rate is, or the cost of capital is 15%. What would be the expected price? Obviously, $10 divided by 15%, right? Roughly $66.67 would be the stock price. The second case is the constant growth dividends. So in this case, the amount of dividends is not fixed, but rather grows at a constant rate. So let's say in the first year, the dividend is, well, assume this is the amount. Then in the second year, it grows to this number, right? So the growth rate is G. Well, in the third year, it will be this, right? It's very easy to see. This is a geometric sequence. So in this case, the PV or the stock price at 0 would be the first dividend divided by 1 year factor. The second dividend discounted by 2 year factor. Goes on and on, right? Forever. We have done this before, so we easily know this would be R minus G as the new denominator. So we can apply this analysis to easily calculate the stock price. If the dividends actually grow at a constant rate, we have an example 6.16. Right? In this case, the amount, the first dividend is $10, and then all the future ones will grow at 3%. So G is 3%. The required return is 15%. So R is 15%. So it's 10 divided by 15% minus 3%. So those are easy questions. Sometimes they can ask you in a different way. Say the price is given, the growth rate is given, and then they can ask you the what would be the required return, right? So that's example 6.17. What do you know is the current stock price is $50. The first dividend is going to be $5 next year, and all future ones will grow at 3%, right? The question asks you, what would be the required return for this stock, right? We can easily set up this equation. 5 divided by R minus G, right? So the the denominator is going to be 10%, then R would be 13%. Right? Again, this is a very simple example. You can also switch. Well, what if I give you R and then I ask you what would be the growth rate G? Right? Okay. Finally, we talk about non-constant dividend. Right. So obviously, this is the most general case, and since it is the most general case, we don't have a general method to deal with this case. We can only use one example to somehow demonstrate for such a scenario what we can do. Say company X has a short-term competitive advantage, and its dividends are expected to grow at a rate of 20% for the first 3 years. 1, 2, 3. Okay, so it's growing at 20%. After that, the competition catches up, so the advantage is gone, and then the dividends will grow at the average rate of 5%. So up to here, 20%, 20%. After, it will become 5% forever. Assume the next year's dividends is $2. Okay, and the required return is 15%. Calculate the current stock price. So if we know the first dividend is 20%, so here it would be $2.4. Here it would be $2.88. Okay, and then you need to times by, for example, for here, dividend 4, it would be 2.88 times by 1 plus 5%, and afterwards you do the same 5%. Okay. So in order to price at 0, what we can do is we first do the analysis for 1, 2, 3. Right. That is something we can see here. The first one is $2, the dividend, right? And we discount by 1 year. The second one is $2.4. We discount by 2 years. And the third dividend is $2.88, and it has to be discounted by 3 years. For all the future ones, they grow at a constant rate of 5%. And obviously, we know how to deal with that, right? That is in this divided by R minus G. G is 5%, right? Okay, but this is the present value at 3, right? If we stand at time 3, all the future dividends, they grow at 5%, right? So we apply the result from the second case. So we can calculate the present value at time 3. Now, in order to go back to time 1, we obviously discount by 3 years, right? Okay, so that's everything. So that's everything you need to do. And once you do the computation, you will get the final number to be $25.33. So again, this is a very special example, right? This is not the most general case we can think of for non-constant dividends, right? Because if you look at the entire timeline, this is indeed non-constant dividends, right? Because for the first 3 years, it grows at 20%. After that, it grows at 5%. But it's a piecewise constant growth, right? Well, piecewise means if we separate the timeline into the first 3 years and all the later years, then the first period, it grows at a constant rate of 20%. For the second period, it grows at a constant rate of 5%, right? That's why we can apply the analysis from the second case. The most general case would be You don't know, right? It can be any number. The gross number can be anything. It may be for certain periods, the amount of dividends is flat, and after that it may grow, if the economy is good. And sometimes the amount of dividends may actually go down if the business is not doing well, like what we are seeing right now, right? So everything can be possible, right? And for the most general case, we simply don't know how to apply the analysis, right? Uh, because we don't know the amount of dividends, right? For this method to work, we need two assumptions. We need to know the future cash flows, and we also need to know the interest rate or cost of capital in order to discount the future cash flows back to zero, right? Only under those two assumptions, we can apply the discounted cash flows to do the pricing, okay? That's not good, right? So now let's talk about a different method. So let's put method one. This is method one, right? This is so-called discounted cash flow. Okay, now let's talk about a different method, method two. Okay, so here we actually apply the PE ratio. So first of all, we need to define this, okay? By the way, this is one of the most commonly seen ratios, if you tune in to any financial news. Let's define what is a PE ratio. So a P for a stock, the PE ratio is the stock price per share divided by earnings per share. Right? Since it is under the per share unit, and you can also talk about for the entire company. That would be the market capitalization divided by the total earnings. Right? That means the unit stock price equals the total market capitalization divided by the amount of outstanding shares. Okay, the earnings per share would be the total earnings divided by the number of outstanding shares. Right. So that's why I have the second equality. So as you can see from here, if you focus on earning, right? Earning is revenue, right? So obviously the higher the EPS. So by the way, the acronym for this is EPS, earnings per share. Holding all other things equal, the higher the EPS, the better the company is doing, right? Because it generates more profits per share, right? For a higher EPS. In that sense, if you look at this PE ratio, it does give you some kind of information, right? Although this definition could fail if right. If EPS is zero, well, then the PE ratio could be infinity, right? Well, or undefined, right? Another case is a lot of companies are not making profits, right? They don't have positive earnings, but they actually incur losses, right? Then when you define PE ratio, it's well, if you really want to define, it's going to be a negative number, right? It doesn't have any actual meaning, right? So it definitely has disadvantages, okay? And when we talk about PE ratio, we usually compare it. What would be the reasonable size, right? So we can do a little Google search, right, to see what would be the average. Let's say average PE ratio for SP 500 companies. What would be right? You can see the mean value and the median, right? It's about 15. So 15 PE ratio is around the average number, right? About 15. We can look at some, hype stocks. Let's say PE ratio of, let's say, Tesla. Right? Tesla is 90 times. Okay. Again, what the average is about 15. Right? So it's much higher than the average. And also, if we compare, if you think Tesla as a automotive company, the average, let's say Ford, GE, those are around 27, and still, it's much higher than the industry average, right? It's 3 times as big as the average industry level. So that's sometimes people think a stock. I mean, when do you have higher than normal PE ratio or higher than average? That's when you pay more, or when you pay a higher price for the same stock or the same kind of stock, right? So in this case, is if you want to invest in auto industry, if you buy a regular, let's say General Motors or Chevrolet, those companies, the the P ratio is about 27, meaning for $1 earning, you pay $27. $27 for $1. So that's the interpretation of P ratio, right? Because P is the price you pay. You pay $27 for $1 of earning, right? But if you want to invest in Tesla, you actually need to pay $90 for $1 of earning. Why? Right? That's because there's too much hype in Tesla, right? So that's usually people call the growth stock, right? You think they have the potential to grow, so you are paying a premium for the same thing you are getting, right? For the same $1 you earn, okay? So if you invest in General Motors, you are only willing to pay $27. But when it comes to Tesla, you are willing to pay $90 for the same amount of earning. That's because you think Tesla has a better future than General Motors, right? That's why you pay higher than the average, right? It can be even, let's say another hype stock, right? Everybody talks about is Zoom. Isn't it crazy? Right? You need to pay $483 for $1 of earning. So you can that's because it has all the market attention, right? So usually, in many cases, we see that when you have a very high PE ratio, okay, in many cases, it indicates that people expect the stock to grow. That's why you are willing to pay more, right? Because your expectation on this stock is that it will continue to grow value. That's why you pay this high premium, right? Because your hope is that in a near future, okay, what you pay as premium right now will be paid off, right? Well, the same thing happened to Amazon, right? So many years ago, many people, the PE ratio of Amazon was high, right? Surprisingly high. But now, if you invested at that time, now your investment would be a brilliant investment, right? Considering the stock price of Amazon, right? Indeed, Amazon grow, right? It grows as expected, right? But of course, it may not be the case, right? So for all the growth stocks, not all of them actually grow in as expected. So it's a reasonable measure, but there are cases that weird things can happen, right? I already mentioned not only growth stocks have very high PE ratio, right? The stocks with nearly no earning, so earning goes to zero, the EPS is surprisingly high, right? That's because That's because the denominator EPS is close to 0. You get a surprisingly high PE ratio, right? Maybe not because people have expectations on growth, right? Maybe because the company is doing terribly, right? Not making money, not generating revenue, right? With nearly 0 EPS, it has a very high PE ratio. So it's a junk stock in that sense, right? Instead of a growth stock. So you really need to actually look at the fundamentals to decide or to value the usefulness of the PE ratio. Okay, but nevertheless, it's a possible way to price because we do have an identity, right? So the stock price may be something we are interested, right? So if you are able to get the PE ratio, if you are able to somehow predict the EPS, you can apply this method to predict the stock price, right? By the way, this is one of the commonly used techniques nowadays, even nowadays, to somehow to get estimate for the stock price. Okay, the reason is simple is because PE ratio, we have a lot of data, right? Okay, we have the data on this specific stock. We also have the data on the average industry or for the entire economy, right? So we have the PE ratio. We have a lot of data, and for a relatively short period of time, EPS is somehow okay to predict, right? You can get this kind of information from many agencies. Let's say Morningstar, right? There will be a consensus, anonymous consensus on EPS on the next reporting day, right? So every quarter, most companies are required to post their earning reports, right? From there, you get an EPS. This is a very important signal for the stock price, right? So if the stock or if the company delivers above expectation EPS, usually there will be a huge jump on the stock price after the trading hours, right? Because all the earnings are reported after 4 o'clock Eastern time, 4:30 or 4 o'clock, and will be before 9:30 a.m. in the morning. So most investors can trade, during this period, right? So by the time when you actually hear the news, when you see the numbers, it's probably already too late, right? But for many agencies, they might be able to get a rather accurate prediction on EPS. Then they can act before the report, okay? And if their prediction is correct, they could make a lot of money, over a short period. You can go to any financial data service like finance and look at the stock price before and after the earning report. Okay, you will see a huge jump for many stocks. Occasionally, I gamble on that. Sometimes, I could make some money. Sometimes I could lose money. What is my recent story? What is my recent story? Recent story was an unsuccessful one. Before the earning report of Lowe's, it is one of the largest home renovation stores, right? The other one being Home Depot. One day before the earning day, I purchased 10 shares of Lowe's. Okay, that's because during the lockdown period, I thought, at least from my own perspective, right? I went to Lowe's many times to buy all kinds of materials to do the renovations at home because I don't need to go to the university anymore. The same, I observed many people are doing the same thing, so I expect their business should be quite robust, right? So I bought their stocks before the earning day. I think about 130, not 130, 160 some dollars, right? The next day it dropped to 148 or 150 around that mark, right? So it was a bad betting, right? But you can see here the price moved down a lot in this case, right? If it moves up a lot, I could easily make quite some money, over one day. right? It's actually over a few hours. So eventually, the earning report was quite okay, right? It somehow, fits the expectation, but it distributed many benefits to its own employees. So the EPS is slightly lower than the consensus, right? And the usual reaction is, if the posted EPS is below the expectation, the stock price is going to go down, right? There's a jump down, and that's the case for the lows, right? So that's my story, right? Nevertheless, let's look at an easy example. Okay, example 6.20. We have a company X. It's a closely held private company, so it's not public traded. Its shares are not traded. Company X has a reported earning of 25 million in the last year. It's a private company, so we don't have the stock price. And then we have another company Y, which is a public company. It's public traded. It's a competitor of X, meaning they are in the same industry. Y earned 100 million over the last year, and the stock price is not 50, $30 per share. So its stock price is $30 per share, and Y has 10 million outstanding shares. So outstanding shares are the shares that people can trade on the secondary market. So those you can buy from stock exchanges. There are non-outstanding shares. Sometimes the original owner might have some other shares in the company that are not public traded. We want to estimate the total market value. So we want to know the market value of X. That's the so-called market capitalization. Okay, so what would be the total worth of company X if it is sold to another company? Okay, so now we apply the PE method. So first of all, we have all the information from Y. So we calculate earnings per share. It will be total earnings 100 million divided by the total number of outstanding shares. So EPS is 10. Well, it's slightly below the SP 500 average. The PE ratio for Y would be price, which is $30, divided by the PE ratio, which is 10. So the the EPS, excuse me, is the 10. So now the PE ratio is 3, right? So we apply this information to somehow value company X. So for X, the market capitalization would be we apply this formula. What is the formula here? So in order to calculate the market capitalization, we can do PE ratio times total earning. So PE ratio, we use it from Y because they are in the same industry, right? And we obviously don't have the PE ratio for X because it's a private company. So it does not have a stock price. So we use the PE ratio from Y, and we know the total earning of X is 25 million. So obviously the total worth of this company would be $75 million. So if we apply the PE ratio method to value this company, we would conclude that company X is worth of $75 million. So that is our conclusion, right? That marks the end of 6.3. We do have 3 examples from our practice question. I already gave you the solutions. Please study those 3 questions. Okay, I will end my video down here.